use variation of parameters to solve the given system. So you are given the system and it's asked you to use the variation of parameters method. So that means for this type problem, you can see you have a non-homogeneous solution. So to find the solution for non-homogeneous solution, first you need to find the homogeneous solution and then find the non-homogeneous solution. Then your final answer is the combination of homogeneous part and non-homogeneous part. So here's the steps you need to do. So I will walk you through it step by step, and I'm not gonna go over these steps because I'm sure that you already learned it. Alright, let's get started. So first, find the homogeneous solution. So you need to have a minus lambda I. What is a? Let's call this matrix A, and then subtract it with lambda. That gives you this matrix, and then find its determinant. It gives you this one. Distribute it, simplify it, and then set it equal to 0. Solve for lambda, you will get 1 and 2. Okay, so 1 and 2 are your eigenvalues. Now for each eigenvalue, you will get a corresponding eigenvector. Let's take a look at the case where lambda equals 1. Plug it into this matrix. It gives you this matrix and then augment it with 0. Okay, so use it. From the first equation, I know that k1 is equal to 2k2. If I choose k21, then k1 is 2. My vector k is 2, 1. Then my vector x1 is 2, 1 e to the t. Doing the same thing, you use similarly for lambda equal to, plug it into here. It gives you this matrix augmented with 0. Okay, so use the second equation. I know that k1 is equal to k2. If I choose k1 1, then k2 is 1, vector k is 1 1, and my vector x2 is 1 1 times e to the 2t. Then my homogeneous solution is equal to c1 times vector x1 plus c2 times vector x2. Okay, now for the non-homogeneous solution, first you need to put this into a matrix. Let's call it matrix phi of t, and then so basically you just exclude c1 and c2 and put the rest into a matrix. Don't forget to multiply by the e to the t or e to the 2t here. Don't just take the numbers down. Okay, and then after that you are going to find the determinant of phi t. It gives you 2e to the 3t. Okay, so then you need to find inverse of phi of t, which is equal to 1 over determinant times this matrix. And in downward diagonal line, you just switch the position of these two, and in upward diagonal line, you just multiply by -1. Okay, so if you do this calculation, it gives you this matrix. Alright, now it's time to find vector u prime of t, which is equal to inverse phi of t times f of t. What is f of t? F of t is whatever left over from vector x. Okay, and then inverse phi of t is what you just found up here. Okay, so here's a little note that is here. So do not switch the order here. Okay, you can do it when you have a numbers or variables, but because you have matrices here, the order does matter. Okay, so if you swap the order, it will change the answer. Okay, so be careful when you multiply matrices together. Okay, so if I multiply these together, it gives me this matrix, and then once I know this matrix, I can integrate this one to get a vector u of t. Okay, so doing that, it gives me this matrix. Right. Okay, now it's time to write vector non-homogeneous solution. It is equal to phi of t times u of t. Phi of t is this matrix, u of t is this matrix. Okay, so again, here's the multiplication of two matrices, so do not swap the order. Okay, so I repeat this many times. because people just think that, oh, okay, so a times b is the same as b times a. Well, it's true when you have numbers or variables, but here you multiply matrices together, so be careful with that, right? So where after I multiply these two together, it gives me this matrix. Simplify this, gives me this one. Okay, so multiply these two, it gives me this. Simplify this, gives me this. Okay, and then your final answer is equal to homogeneous solution plus non-homogeneous solution. Okay, so that's it.
If you find the video is helpful, feel free to give it a like, share, and subscribe to my channel in order to receive the most current videos. Don't forget to hit the bell so that you won't miss anything. I'll see you next time.